Good afternoon to all of you. Today the lecture number 9 of your engineering mechanics or your applied mechanics you can say. Today is 22nd April 2021. So in last class we have studied about the mechanical advantage, velocity ratio, input of the machine, and what is the output of the machine, efficiency, types of machines, ideal machine, real machine, law of machines, maximum mechanical advantage, reversible and non-reversible machine, and the conditions of reversibility. So this in previous lecture we have seen this and different formulas we have also seen. So these we have seen in the previous lectures, and today inshallah we will learn about the velocity ratio for the different machine. This is also we have seen that how the types of machine are classified based on the efficiency of machine. If the value of eta, that is efficiency, is greater than 50%, then we will say it is a reversible machine. And if the value of eta is less than 50%, it is an irreversible machine. And if the value of eta is exactly 50%, then we will see that machine at the point of reversing. So all these things we have studied in the last class. Okay, and then reversible and non-reversible machine and their conditions of reversibility and non-reversibility we have seen, and then the actual machine, or we can say the real machine definition. What is a real machine? Uh, when the efficiency of the any machine is less than 100% is a real machine, and if the efficiency is 100%, then machine is giving the 100% output, then that machine is said to be ideal machines. And their characteristics also we have seen in the previous class. And we have seen the law of machine, that is P is equal to mw. M is the slope, W is the load lifted by the machine, and C is a constant, that is initial load required to start, or you can say the initial effort to lift the machine, that is C. So this, when there is no ideal condition for real machine, the P is equal to mw plus C. But if the ideal relation between the load lifted and effort applied is known as the law of ideal machine, then C value will be 0, and then P is equal to mw, where Pi is the ideal effort, W is the load, and that is मलिक असजद क्या टाइम हुआ है बेटा, टाइम पर ज्वाइन करो लेक्चर, कभी भी आ रहे कभी भी जा रहे, डोंट डू दैट. So this we have seen, and then we have seen the ideal effort. Ideal effort, that is Pi, is equal to, it is a ratio of load to be lifted to the velocity ratio. Ideal load is the product of effort applied and velocity ratio. So it is a product of effort applied and the velocity ratio, that is the ideal load. And the load which can be lifted by an effort P when there is no friction is called as ideal load. If there is no friction, this condition is there, then lever arm, we have seen the rigid bar which provide to machine, so apply effort is called as lever arm. the शीर्षक was time now. You should take care and join on time. And then we have seen the maximum mechanical advantage, and it is nothing but because C by W is very less and it can be neglected. The maximum mechanical advantage is nothing but the inverse of the slope, that is 1 1 upon m. Then you can see the maximum mechanical advantage, maximum efficiency is already covered in previous class. And the maximum efficiency, it is a ratio of maximum mechanical advantage to the velocity ratio into 100, because it is always, the efficiency is also always in percentage. Therefore that's why you have to multiply with the 100. Okay, and then our lectures today, the outcome of the today's lectures, at the end of the lecture you can able to know the effort lost in the friction, load lost in the friction, velocity ratio for simple axle and wheel, and differential axle and wheel, worm and worm wheel, single purchase scrap, double purchase scrap, simple screw jack, Weston differential pulley block, and gear. So we will complete this if possible. So velocity ratio for different machine, you have to see how you can find out. So first we should know what is the velocity ratio. What is the velocity ratio? It is the ratio of distance traveled by effort traveled by effort to the distance traveled by the load. It is distance traveled by effort to the distance traveled by the load. This is the ratio is called as a velocity ratio. And for the machine, for each machine, it is similar or constant. It is not changing. है ना? So for the before that we will see the effort loss in friction, that is PF. So what is PF? This is nothing but the effort loss in friction. It is difference of actual effort required, yani real effort required to lift a load W and ideal load required to lift the load. ये डिफरेंस किसका है? इफर्ट लॉस इन फ्रिक्शन अगर हम मालूम करेंगे तो एक्चुअल इफर्ट यानी जो असले में रियल में हमको इफर्ट लगेगा लोड इस उठाने के लिए, दैट इज कॉल्ड एज एक्चुअल इफर्ट, माइनस आइडियल इफर्ट. आइडियल इफर्ट मीन PI. So if there is no friction and we will lift the load, that condition is ideal effort, that is PI. So what is the effort loss in friction? How we will find out? The PF, we can find out the PF will be, it is nothing but you can see the P minus PI. Yani in P, finding out the P effort, that is nothing but distance traveled by the effort. Load required to lift the effort is load required to lift is nothing but effort. So that effort, if it is in real load required with friction, then that is called as P. And this P is, we are considering the friction, है ना? Because friction, this is opposes the motion, this is Newton's law. And then we can see here If there is no friction, that is Pi. So it is a Pi is the the product of load upon VR, that is velocity ratio. So how you can find out the loss of friction, that is Pf. It is P minus Pi, and Pi is W upon VR, load upon the velocity ratio. Similarly, load lost in friction, so that is Wf denoting. It is a difference of ideal load lifted by effort P and actual लोड लिफ्टेड बाय एफर्ट पी. तो यहाँ डिफरेंस क्या है, इसमें लोड में है, ऊपर डिफरेंस क्या था, एफर्ट में था. तो लोड effort lost in friction you can find out from this. Load lost in the friction you can define by from this. तो effort loss में आपका effort आएगा और load loss में आपका load आएगा. तो difference between the ideal load minus the real load is nothing but what, load lost in the friction, and it is nothing but, you can write down, because Wi is P into VR. So Wi is a product of, you have seen earlier, P into velocity ratio. So from these formulas you can find out the effort loss in friction and load loss in friction by using these formulas. Then we will see the simple and axle wheel. So we know that the velocity ratio, that is VR, it is a ratio of distance traveled by the effort and distance traveled by the load. So this is the ratio of that. तो यहाँ पर सिंपल एक्सल और मशीन हम अगर लेते हैं, दिस इज द एक्सल and this is the wheel. Okay, so effort, when we pull this screen, this string or rope, then what happen, this will unbound, this will unbound the rope, and the effort is like that. And what happen, this string is winding, okay, and the load is lifted. This is the function of simple machine and axle, simple axle and wheel. तो यहाँ क्या हो रहा है कि ये जो डायमीटर है व्हील का, क्या है, इफर्ट जहाँ पर लगा रहे हम लोग, इट इज डायमीटर कैपिटल डी, एंड द स्मॉल डी इज डायमीटर ऑफ योर एक्सेल, है ना, ये एक्सेल है और इसकी वजह से हमारा ये अपलिफ्ट हो रहा है लोड. व्हाट इज द वेलोसिटी रेशियो, डायमीटर ऑफ एफर्ट व्हील या डिस्टेंस ट्रेवल्ड बाय द effort to the distance traveled by the axle. यहाँ diameter distance traveled by the load is small d, and it will come in denominator, and the effort is, this diameter is capital D. So capital D to the small d is nothing but velocity ratio for the simple axle and wheel. So likewise for each machine you can find out the velocity ratio. So you know what is the velocity ratio? Its definition, that distance traveled by the effort to the distance traveled by. So each machine you have to check this. We will try to see one video if possible. You can see this video if it is useful to you. when we have to move a real heavy load, we have to use a great deal of force pushing because like friction for resisting the motion. You are seeing the wheel and axle solve this problem, and easily we can move the material or load from one. It is axle and the wheel. Our material on the axle and we are similarly your vehicle are like this. This load vehicle on the axle and the force. This load heavy load is shifting to the back. So that's this simple mystery machine we are studying. Many such video lectures are available. Animation videos are there where you can easily understand the working of the different types of machines. Another example, wheelbarrow, car, steering. You can see a small movement, capturing the movement is there. Door handle, rolling pin, bicycle is other example. Okay, so this sorry, the working and procedure of we have seen the simple axle and wheel. Similarly, for we will see the velocity ratio for the differential axle and wheel. You see here in differential axle and wheel, you can see here this is the effort wheel. Okay, so it is visible to you. This one is the effort wheel. This is the effort wheel. Okay, you can see this is effort wheel and diameter of the effort wheel is capital T. है? And then you can say on axle there is two uh, different diameter axle is there, smaller axle and bigger axle, है? And the weight is attached with the this pulley. This is all attachment you can see. Smaller axle, bigger axle, effort wheel, and the load is controlled by the pulley movement. And here you can see that when we have to lift the load is lifted here. What will happen? You have to pull this rope. You have to pull this rope. What is time, Muhammad Rashad? It is not time to join the lecture. Huh? Take care from next time. Your attendance will be considered if you are joining lecture after 10 minutes. So you can see here the when we have to lift the load upward, then we need to pull this rope downward. Okay. So if you pull this diameter, the wheel of your effort wheel will rotate. Okay. So what is the D is the diameter of your effort wheel, capital D, and D1 is the diameter of the larger or bigger axle, and D2 is the diameter of smaller axle. So you can see here very it is given. You can see the diameter D1 here. You can see here is that sorry something wrong. Diameter something is wrong. Sorry. What happened? Again we will select the pointer. You can see here the diameter D1 for bigger axle. diameter d2 here at a small axle. Okay. So when we find the velocity ratio, you know the velocity ratio, it is nothing but the distance traveled by the effort y to the distance traveled by the load x. Now what happen here? When we apply the effort or we when rotate the wheel, effort wheel, then this rope will wound in larger axle and the it will release from the small axle. So distance traveled by the wheel to lift the load, we are saying that wheel and differential axle, it is nothing but d twice a d divided by the diameter of large axle minus diameter of small axle d2. So this is the velocity ratio for wheel and differential wheel. तो कैसे वर्किंग करता है ये कि अगर हम जब इफर्ट व्हील इसको लोड को उठाना इफर्ट व्हील वी विल रोटेट and the string or rope attached with the pulley, the bigger axle will rotate and it is owned on the bigger axle and unowned on the smaller axle, the string, and the load is lifted by this action, and this is called as differential action and wheel. Here also now another wheel, worm and worm wheel, worm and worm wheel. Here you can see the worm screw is attached with the worm wheel. You can see here, this is the worm screw and this one is the worm wheel. Okay, and this one is our effort wheel. Okay, now here to lift the load, how the mechanism is there, we'll apply the effort here, and we'll pull down the load, and what happen, this worm screw will rotate and simultaneously the worm wheel will rotate. So this wind the rope and then the load is lifted. So it is the movement of the worm screw with the worm wheel is attached. So here you can see that the diameter D, capital D is the diameter of your effort wheel, and capital is number of teeth on the worm wheel, this number of teeth here on the worm wheel, and small r is the diameter of or radius of the worm wheel. Radius of load drum you can say at the worm wheel is nothing but small r1 or diameter d, and small d is the capital D is the diameter of the effort wheel. So effort is nothing but related with the this wheel and the worm screw. So that's why it is a ratio of, you can see the D to capital D and capital N to small n. So capital D to D, capital N to N is the ratio of your, that is velocity ratio of one wheel, worm and worm wheel. So this worm and worm wheel, you can see how it is working, worm and worm wheel. Sorry, this is worm and worm. We will go for this. Control C. Now you can see the video how the worm and worm wheels are working. Now these heavy loads we have to lift by the arrangement of worm wheel. This is the effort wheel, and you see the worm wheels are rotating. I know worm is rotating and the worm wheel, and they are lifting it. See this load is lifted. Now it is stop. The lock is there. You can see the ratchet hook behind the ratchet wheel. तो रिटर्न आपका यहाँ पर मूवमेंट नहीं होगा. इट इज लॉक. दैट्स व्हाई द worm and worm wheels are using in practice. Okay, for lifting the heavy load. So you understand this better. So this is the application of this your worm and worm wheel. Now we'll come to the another sorry, what is in here? Okay, select the pen. Okay, what is the time, Mohammed Mustafa? Why you are joining late? Just during the lecture recording, you are coming late, and it is recorded also. But still, you are doing this. If you are to join the lecture on time. Then will come the single purchase scrap. In single purchase scrap, the attachment you can see here. There is gear box. This one first gear, and this one is the second gear, and this is your effort wheel, and their diameter D. The axle or load drum you can say, their diameter is small d, and then you can see the pinion wheel or gear or spur wheels or main gear you can say. Here the photograph is also there. This the single purchase scrap. You can see this. It is visible to you. This is your I will enlarge. So this is the effort wheel. This one is the effort wheel attached with the string or wheel. Sometimes you provide handle also. You can see this is the pinion gear. Small gear is called as pinion gear, and the big gear is called as a spur or the main gear. Okay. So how it is working? When we have to lift this load, the rope will wound in the drum, but when we apply the load here downward, we pull the rope downward, then this wheel will rotate, and this wheel rotate the pinion wheel, and pinion wheel rotate uh, the spur wheel, and the spur wheel rotate and wound the string on the load drum, and the load is lifted. This is the procedure. Now here you can see the how the velocity ratio. It is the effort किसकी वजह से हो रहा है? Diameter of effort wheel. Okay. और क्या हो रहा है? Number of teeth on the spur wheel, that is N1. It is rotating the drum. है ना? So therefore these two, they are rotating the drum, that they are the providing the effort, and number of teeth on pinion wheel is the load we are lifting. and the small d diameter of that axle or drum or load drum, you can say, which are actually the string attached to lift the load. So this is the working procedure of the single purchase crab. And then when we find the velocity ratio, dn1 the efforts and d and n2 are the load lifted. So d is the diameter of effort wheel and small d is the diameter of your drum wheel where the load is lifted. N1 is the number of teeth on a spur wheel or main gear, you can say, and N2 is the number of teeth on the pinion wheel. So this is the velocity ratio for the single purchase crab. So easily you can find out this velocity ratio, and this formula you should remember, and this you should explain in the examination. The question is asked. Then you will see the double purchase crab. डबल परचेस क्रैब में, सिंगल परचेस क्रैब में आप देखेंगे वन पिनियन एंड वन स्पर व्हील इज देयर. In double purchase crab you will see one pinion, one spur, again pinion and again spur, then the load drum is there. So in this case you can see that in a double purchase crab the effort is applied, yani we are pulling this string, or we can otherwise rotate the handle, okay, to unwound the string, but generally we are applying the load or to lift the load. So where is the lift the load? We will lift the load here, okay. So what happen when we apply the load? It will how this effort wheel rotate the pinion wheel rotate the this spurs gear, and then is the same axle, the pinion 2 is attached, and it will rotate again the gear of the second spur, second gear, it will rotate, and because this drum is attached with the spur, then it rotate the string on the string and the load is lifted. So we are applying the input here, here, effort, and then we are getting the load lifted. That is our output. Load lifted is nothing but our output. The velocity ratio of this double purchase crab, you can see, because here two wheels are there. So first one, the D effort, diameter of effort wheel divided by diameter of drum is small. The N1 is the diameter of N1 is the number of teeth on the spur wheel, and it is a ratio of number of teeth on the pinion wheel, N2. Then again there is an attachment. In symbol is purchase crab, only one attachment is there. Then this is N1 and N2 only. But what happened here? In double purchase crab, there is again pinion wheel, and that is the diameter of spur wheel number 2 is and number of teeth in the spur wheel, and then number of teeth in the pinion wheel, that is N4. So this is the formula of your velocity ratio, that is for the double purchase crab, D upon small d, N1 upon N2 N3 upon N4. N1 is the diameter of teeth on spur wheel number 1. N2 is the diameter of teeth on the pinion wheel number 1. Then N3 is the number of teeth, not diameter, number of teeth on the spur wheel number 2. And N4 is the number of teeth on the pinion wheel number 2. So it's working of your double purchase crab. Okay. So we are applying the effort here, but their effect we have seen here, and the load is lifted. Now we'll see the स्क्रू जैक. स्क्रू जैक कहाँ पर यूज होता है, कोई बता सकता है? वेरी कॉमन, बहुत कॉमन है, हम यूज करते हैं डे टू डे लाइफ में. और मैंने बताया अभी आपको लास्ट क्लास में कहाँ पर यूज होता है. आई थिंक सो you know, to lift the car we are using this screw jack, simple screw. तो कार के जो जैक होते हैं they are simply the screw jacks are there, and very easily we are rotating by the use of handle, and you can see the screw jack, it's working. You can see here this head is there, and there is hole to fix the handle, and the handle when we rotate, then due to the screw action it is lifting or going down or going up as your direction of movement of your head, है ना. So if you are to lift the, what is the time, Saif Ali Khan? You are coming for the attendance only? क्या टाइम हो गया अभी? You should join on the time and you are disturbing the class. तो यहाँ पर क्या हो रहा है हमारा, we are using the simple screw to lift the car, है ना. तो हेड है, गियर स्क्रू है, and the center to center distance between this gears or threads on the screw, they are called as pitch. तो पिच ऑफ द स्क्रू, एक रोटेशन होगा तो आपका इतना एक पिच आपका बढ़ेगा, ऊपर होगा. तो यहाँ पर इफर्ट कहाँ पर लगा रहे हैं हम लोग, इफर्ट वी आर लगा मेकिंग ऑन दिस head. We are rotating the head, and screw is due to gear, or you can say the thread is there, it will coming up and down. This is the working of your screw jack. And the velocity ratio, you can know that the moment of this effort, we are applying the effort. Okay, so what is effort? So you know the circumference of your circle, one round if you complete, that is pi d, it is a fly, and divide by pitch, yani one rotation of this pitch, it is nothing but it is lifting the load. So one motion of this is called as the diameter of this thread, and one rotation is called as the pitch, and the pitch is distance between the these center to center of the threads. Okay, so this is called as pitch. The velocity ratio for screw jack is nothing but the circumference of that your top, that is pi into d, if it is circular, and it is always circular, you can see here, and we are rotating it, either in clockwise or either in the anti-clockwise to lower a load or to lift the load, and divided by the load lifted by the screw, that is rotation of your pitch, is nothing but the velocity ratio of, of your simple screw jack. Now we'll come to the Weston differential pulley block, and then we'll see the geared pulley block. The Weston differential pulley block is you can see different Weston differential pulley block. Weston is the scientist on the name of scientist that pulley block is Weston pulley block, Weston differential pulley block. So here you can also see the working of this on this video, how the working of this Weston differential pulley block. And generally it is uh, uh, using in our day-to-day life. It's commonly used in to lift the heavy load. The bigger pulley and the smaller pulley, and the chain is continuous. It is endless chain. There is no end because they are circular motion. They are connecting and rotating. Okay, the chain are one of the chain. We are applying the effort, and that is the P. Other end, what happened? We are attached with the pulley, and then the lower block it will lift the load. So when pulling with the in the downward rotation, the load is lifted because it is rotating the smaller pulley block and bigger pulley block simultaneously, and the lower pulley block which is attached with the load is also lifted. This rotation is endless and continue, and the load is lifted. Okay. Effort is always input and load is always the out. So you have seen the how it is its motion. So you can see here the Weston differential pulley block is attached with the two different chain we are joining to, to make a endless chain, and when we are this both chain is attached with this, and come to the lower chain, and this is attached with the pulley block here, and then again it moves, sorry, moves to the greater one, and the weight is attached with this. When we move the chain, then we rotate the smaller, and this also weight and the greater weight, and this weight is lifted. So this is Weston differential pulley block. So diameter of bigger pulley is capital D. Diameter of bigger pulley is the capital D, or you can say T1 is the number of cog or teeth on the bigger pulley. T2 is the number of cog in lower, smaller pulley. Then D is the diameter of smaller pulley. So what is the velocity ratio? So velocity ratio here is 2D upon D minus D. Or in case of number of teeth, if you say 2T1 divided by T1 minus T2. Okay. So this is the velocity ratio for the Weston differential pulley block. Similarly, the geared pulley block and the velocity ratio for the geared pulley block you can easily define here. Number of cogs on the effort wheel, number of teeth on the pinion wheel, number of teeth on the spur wheel, and number of cogs on the load wheel. All these are we will see in the next class, geared pulley block, and also we will try to solve some example on this unit number 2 on our tutorial class on Saturday. So I expect that all the students should join on time. We will complete, and I will request all of you that you should join the lecture on time so that the no disturbance will be in classroom. Okay, so we'll stop here because we have time over. Thank you for joining.